All right, in this video, we are going to start talking about the graphs of the other trigonometric functions. We've already talked about the graph of sine and cosine. So the first one that we're going to start talking about of the others is tangent. And so to take a look at the graph of the tangent of x, what we're going to do is start plotting points here. All right, and we're going to start at minus pi over 2. And we'll talk a little bit about why we're going to start there a little later on. So what we would do, right, in order to start getting these points that are on the graph of tangent x is, again, to take a look at the unit circle, right? That's how we originally defined the tangent function in terms of the unit circle. So if I look at negative pi over 2, right, that is not one of the values that's marked normally on the standard unit circle. But remember, what that would mean is that we would go pi over 2 units in the clockwise direction, right? Pi over 2 we know is the same as 90 degrees, right? So if we went pi over 2 units in this direction, we would be down here at this angle, and the point on the unit circle would be negative 0, negative 1. So remember that the tangent is sine over cosine, right? So tan x is sine over cosine. All right, and so at minus pi over 2, looking at the unit circle, the cosine would be 0 and the sine would be negative 1. So when we go to make that calculation as to what the tangent is, it would be negative 1 over 0. And here we have a division by 0. Division by 0 is undefined. All right, so it turns out you can't take the tangent of minus pi over 2. So that means that, or negative pi over 2. So that means that negative pi over 2 will not be in the domain of the tangent function. You can't take, it's undefined there. So you can't take the tangent of negative pi over 2. All right, moving on. The next point would be negative pi over 3. So again, pi over 3 is up here, right? That's the same as 60 degrees. Negative pi over 3 would be down here, right? It's the same. It's going to have the same cosine and sine as 5 pi over 3 does. All right, and so we can look at the sine, or cosine and sine. The cosine's 1/2. The sine is negative square root 3 over 2. So the value at negative pi over 3 is going to be negative square root 3 over 2 over 1/2. And so that's going to be negative square root 3 over 2 times 2 over 1. And that's going to come out to be, these 2's cancel each other out, and it will wind up to be negative square root 3. All right, and you can see that's the point that we have here, negative square root 3. All right, and so we would keep doing that for all of these points from minus pi over 2 all the way to pi over 2. Right, and some are easy to calculate. For instance, if we did minus pi over 4, that's going to be negative square root 2 over 2 over square root 2 over 2. That's going to be minus 1, right, because the two numbers are opposite of each other. And another easy one is up here at 0. It's going to be 0 over 1, which is just 0, right? So So that's how I'm getting these values here. And then at pi over 2, it's also undefined because at pi over 2, you'd have sine, which is 1, over cosine, which is 0. That is also undefined. So the tangent function is undefined at pi over 2. So that's how we're generating these points here. All right, so what I'm going to do then is to graph these, plot these points out. So minus pi over 3, minus pi over 4, minus pi over 6, 0, pi over 6, pi over 4, pi over 3. All right, so I get minus square root 3, minus 1, minus square root 3 over 3, 0, square root 3 over 3, 1, and square root 3. All right, so you can see that I'm starting to get this kind of wave-looking thing through the origin right here when I graph those points out. So if you kept continuing graphing a lot of points out, right, between minus pi over 2 and pi over 2, that's going to generate the graph. So you can see it's kind of going up really rapidly here. And if you do that, graph that out, then you can see where those points are located here. All right, and so if you graphed a lot of points out, then you would see that. And let me turn the steps so that it is a multiple of pi and a little easier to see. All right, so here's where we started at negative pi over 2, right, on our points that we plotted. It's undefined there. And so you can kind of see what's happening there. At minus pi over 2, you're going to have a vertical asymptote of this function. In other words, the graph is getting closer and closer to this horizontal line at x equals minus pi over 2. I'm going to draw that in as a dotted line, meaning it's not on the graph, but it's not actually part of the graph, but it's easier to see the vertical asymptote. So the graph of tangent is getting closer and closer to negative, to this vertical line x equals minus pi over 2. And likewise over here at x equals pi over 2. So here is another vertical asymptote at pi over 2. So everywhere that the tangent function is undefined, you're going to have a vertical asymptote of the tangent function. Okay, so that's what the graph of tangent looks like. All right, and so let's talk about its properties. All right, so the domain of the tangent function is all real numbers x, where x is not equal to 2k plus 1 over 2 pi, where k is an integer. So now that might look like a complicated way of writing this expression down. What exactly does that mean? A lot of times people will get tripped up on that. This is basically just a short way of writing down an infinite list of numbers. Okay, so if you look at the graph, there are going to be infinitely many of these places where the tangent is undefined. And so we can write all of the places down basically using this formula here. So let me talk for a minute about that, because you will see that quite a bit. All right, so first thing that you need to know about that is what the integers are, right? The integers are just the whole numbers together with 0. I'm going to draw these kind of spaced out. These are supposed to be commas. So 0, 1, 2, 3, and so on and so forth, right? 4, 5, 6, 7, 8, 9. And then also the negatives, so the opposites of the whole numbers, like so. And that list of numbers extends infinitely far off that way too, right? -3, -4, -5, and so on and so forth. So that's what the integers are. And then you're given this little formula here. X is not equal to 2k plus 1 over 2 pi. So okay. And so that little formula will tell you a point that's not in the domain corresponding to each one of these integers. So for instance, for zero, if I plug a 0 in there, for k, and work this out, 2 times 0 is 0, 0 plus 1 is 1, so I'd have 1/2 pi, and 1/2 pi is the same as pi over 2. All right, so that tells you a place that's not in the domain of pi over 2. In other words, a place where the tangent function is undefined. And we can see that that's this place right here. Okay. And then likewise for all of these other points. So for instance, -1, if I plug that into this formula, it's going to tell me another place in the list. So if I work that out, I'm going to get -2 plus 1 over 2 times pi. That's going to be -1/2 pi. That's the same as minus pi over 2. Okay, and you can see that, again, there is a vertical asymptote here, right? And so the next one you can see is going to be over here at 3 pi over 2. That's the one that you would get if you plug a 1 into the formula. All right, so I get 3 on top, 2, so that's 3/2 pi. Okay. And then if I did the same process, I would get 5/2 pi. And then 7/2 pi for if I plugged a 3 in. Right? So for every one of these integers, this is going to give you, if you plug that number into this formula, it's going to give you a place where the tangent function is undefined. And same thing here. Here you'll get -3 pi over 2. All right, so this notation is just a really short way of writing down this list. Okay, I can write it down with just a few characters, even though it's an infinite list, right? It keeps going on and on this way and on this way. But that's basically all it is. You take an integer, you plug it in this formula, it's going to give you a place where, you know, the tangent function is undefined in this particular case. Okay. So that's all this notation means, and you need to kind of get used to that because you're going to see it over and over again in the in this class. Okay. All right. So there are infinitely many places where that are not in the domain of tangent, right? Likewise, at each one of those places, you're going to have a vertical asymptote, right? And so the vertical asymptote is going to be x equals these values as well. So x equals minus pi over 2 is a vertical asymptote. X equals pi over 2. X equals 3 pi over 2 is going to be a vertical asymptote. All right, meaning that those are lines, vertical lines that the graph of tangent gets closer and closer to. And it has infinitely many of those. Okay. All right, now the range of tan x, remember the domain is basically the set of all inputs, the set of all real numbers that you can plug in to the function and get a valid real number output, right? So as long as you don't plug in minus pi over 2 or pi over 2 or 3 pi over 2 or any of these numbers, you're good. You will get a number out as the answer. If you try to plug in pi over 2, then you're going to have problems, right? You can see it says it's undefined on your calculator. If you do that, you might get an error, or a 3 pi over 2. Okay, so the domain is basically the set of all numbers that you can plug in to the tangent function, right, and or whatever function you're talking about, and get a valid number here. So something like pi. If I plug that in, right, to the tangent function, I get 0. So that's a perfectly good output. And so the range, right, the range is the set of all outputs for numbers in the domain. So in other words, what numbers can you get out? And so here, the fact that the range of tan x is negative infinity to positive infinity means that any number, any real number, you can get out as an answer. Okay, so no matter what numbers you pick, that number, you can find another number to plug into tangent to get that number as an output. So for instance, if you said, I want this to come out to be 15, well, what number can I plug in to get 15? That would be arctan 15, and the output will come out to be 15. Or if I wanted 300 for the output, I would plug in this number. And now that might be confusing because we haven't talked about what those are, but it's this number right here. If I take this number and plug it in, it's rounded off a little bit, but you can see it's pretty close to 300. So no matter what number you pick, right, I can find another number to plug in to get that number as an output. So any number is an output of the tan function. All right, finally, the period of the tangent function is pi. Notice that's different from sine and cosine. With sine and cosine, the period was 2 pi. For tangent, it's just pi. So remember what the period is, right? It's the, oops, I erased all my asymptotes, which I didn't want to do, but, and that, man, keep erasing stuff. Okay, so that's what tangent looks like. Again, and so remember, what is the period? The period is the smallest number for which the graph repeats, right, itself. And remember, all the trigonometric functions are periodic. So you can see right here, if we start at minus pi over 2 like we did before, you can see that one complete cycle of the graph goes from minus pi over 2 to pi over 2. And then a new cycle starts up. It starts repeating itself right here. So if you take pi over 2 and subtract off a negative pi over 2, that's the same as pi over 2 plus pi over 2. And that comes out to be 2 pi over 2, which is just pi. All right, so what that means is that the distance from minus pi over 2 here to pi over 2 is pi units, okay? And so that's the period. It only takes half of the distance for the tangent to repeat itself. You can see here's another period, here's another one, and so on and so forth, all right? So that is the period of the tangent function. Okay, in the next video we will talk about the cotangent function, which is very, very similar to the tan function.